Hey everyone, this is Neha and I'm going to be talking about hypothesis testing for two proportions from independent sample. Okay, to test the hypotheses, we have a problem right here wherein we have two groups of randomly selected infants of 2 months of age. One group is administered drug Prevnar, the other one is administered control vaccine. Both of them experience fever as a side effect after their first dose. We have to suggest whether a higher proportion of subjects in group 1 experience fever as a side effect than in group 2 at alpha equal to 0.05. For that, we have the Prevnar group, which is our group 1. 107 infants experience fever out of a sample size of 710. In our group 2, which is with control vaccine, we have 67 infants experience fever as a side effect out of our sample size of 611. We have to satisfy some conditions before we can do hypothesis testing. One, it has to be a randomized experiment, which is stated in the problem that it is a randomized experiment and the group infants were randomly divided. Second, the population, the sample size has to be less than 5% of the population. Over here, we are considering all the infants about 2 months and old as a population, so our sample size is definitely less than 5%. And we also have a formula here that we can use to calculate. Third, our sampling distribution should be approximately normal. We have a formula right here to make sure the product of this should be greater than 10 for it to be normal. Over here, the p-hat value is calculated as p-hat is equal to x1 over n1. The product of this one is, for the group 1 is 91, which is greater than 10, and this group 2 is 60, which is greater than 10, so the distribution is approximately normal. Next, we're going to list our null hypotheses. Because we're dealing with sample proportion, it's going to be P1 equal to P2. And our alternate is going to be P1 greater than P2, because we're trying to see if there's a higher proportion of infants experiencing fever in group 1 versus group 2. Since it's greater than, it's going to be a right tail test. Our first way to do the testing is via a classical approach method. In this, if the test statistic falls within the critical area, reject the null. Now, to find out the test statistic, we use our T83, T84 calculators. We're going to hit on stat, we're going to go on test, we're going to go on 2PROPS Z test. Because we are dealing with two proportions, we're going to enter all our x1, n1, x2, n2 values. Since we are trying to do greater than, we're going to select that option and calculate. We see our test statistics 2.199 over here. So that's what we list as our test statistic. Now, to find out the critical value, we again go back to our calculator. We go for second bars, inverse norm. Since it's a right tail test, we're going to do 1 minus 0.05, 1.645. We have a 1.645 value lying right here, and then we have our test statistic lying here. So it does lie within the critical area. So if it falls within the critical area, we're going to reject the null. We have another method to do this by p-value approach. If the p-value is less than alpha, we reject the null. We're going to do this in the same way. We're going to go to our calculator, stat, test. We're going to again use the 2PROPS Z test. Enter the numbers x1, n1, x2, n2. Select the greater than because we're doing that testing right now. Hit calculate. We do get a p-value right here. That's what, and that we have a p-value right here at alpha is 0.05, so it's less than, so we reject the null. To conclude, we do have sufficient evidence at alpha 0.05 to conclude that a higher proportion of subjects in treatment group taking Prevnar experience fever as a side effect than in group 2. Thank you.